Hey kids, welcome to another math video. This is module 6, lesson 8, and it is the homework. Now, of course, you should be doing the homework on your own, and you should only use these videos as a backup, kind of an emergency, like, did I do it right? And you should also be listening so that you can understand what's happening with these steps. If you made a mistake, finding your own mistake through the correcting process is still a great way to learn. So let's jump in, and I hope you already have your homework done so you can check what you did and why. So, and also become a subscriber on here on these videos for Mrs. Etness's channel. That's my channel. It really does help. If you are a subscriber, you will be notified when I make a new video. So let's jump in. Complete this table such that, and here is that crazy word. Why can't they just say so that? I don't know. They want to keep you on your toes. Such that each y coordinate is 4 more than the corresponding x coordinate. A lot of big words here, but really what it says is what you want to have is for your y, you want it to be equal to 4 more than means you're going to add 4 to your x. Now this is all kind of backwards because usually we take our x and then we go this way. So if you want to turn it around and take your x, add 4 to it, you will get y. Same thing, because remember, commutative property of addition, you can move things around and you'll get the same number. So using this formula, you can come up with whatever numbers you want. You don't have to use my numbers, but what you do need to do is look at the number line and see what you're counting by. This number line has only the even numbers marked. That doesn't mean they're counting by 2s. It just means that every other one is marked. So they're counting by 1s, and so the whole numbers are marked. And you can label just a few to help remind you that you're counting by 1s. Always look at the number line to figure out what you're counting by, because sometimes it's halves, sometimes it's thirds, sometimes it's fourths, whatever. You got to pay attention to that. Now we're going to go to the table, and you think of 3 numbers in here that, and I would say let's keep it under 8 or 10, because when you add 4 to it, if you add 4 to 8, you're going to be at the edge. And so even if you had 10 here and you add 4 to it, you're going to end up with 14, and that's off the graph. So you have to look at your final number that you have to stay below, and it needs to follow this rule. So it's got to be 4 below that, so that when I do have my maximum number, let's pick 8, then 8 plus 4, 9, 10, 11, 12, there's my end of the graph. So we'll be able to put 8, 12 as one ordered pair on our graph, but the other x's should be below 8. So let's try like a 2 and a 4. You can choose odd numbers if you'd prefer. It's really up to you because they will follow the rule. So 2 as your x plus 4 makes 6 for your y. And then 4 as your x plus 4 makes 8 for your y. Now you're going to plot each point on the coordinate plane, and then we're going to use a straight edge to construct a line connecting these points. So 2, 6, remember, always use the x-axis first before y. Look how nicely it points to the y. I didn't even do that on purpose. Okay, so we're going to do a 2, 6, 2, 6, 4, 8, 4, 8, and then 8, 12. And we're going to connect our points. And I always put my little lead down, and then I kind of turn my ruler so that I will have exactly, I like it to go right through the corners. And I'm really precise, and I've noticed that 10-year-olds are not very precise. So just saying, use a straight edge, because freehanding, not really working for you. Okay, give the coordinates of 2 other points that fall on this line with x coordinates greater than 18. Okay, so this number here is your x value, and it has to be greater than 18. So why don't we just start with like a 20, okay? Now, the other y, the y value for this has to follow this rule. So if you have 20 plus 4, you would have 24 for y. This point, when I'm way out here, it will still be on this line because it's following the rule. It's all about the rule, okay? And the rule is all about the relationship between the x and the y. You can come up with any x you want as long as when you add 4 to it, you have the correct answer here. So whatever x you want that's greater than 18, you can even put 100, or that's what the kids are doing. They're like, I want 1,000,000. Okay, you can do 1,000,000 as long as you have 1,000,004. Okay, so it's whatever you want for the x, but your y would be 4 more than that. Okay, as long as you guys are clear on that, your line should be crossing through the y-axis at the 4. If that looks real good, you're ready to move on. Okay, next one. Crooked. How about that? Straighten you out. Complete this table such that, or so that, each y coordinate is 2 times as much as its corresponding x. So we're going to take our x's and then we're going to multiply by 2. That's what 2 times as much means. And then we will get the y value. So you can come up with anything you want for x, but remember, when you double it, you don't want to be past 12. So you don't want to put 20 here. Don't put 20. That's too big. Don't even put 10. That's too big because 10 times 2 is 20, and that will be off the graph. So you want to do nothing more than half of your maximum value. So 6 is our maximum x because 6 times 2 would be 12. So that's how we know we don't want to go off the graph. Your other x values could be 1, 2, 3, 4, or 5. And looking at the graph, you want to make sure the number line is counting with numbers you can use all the way up to here. So let's use 2, 4, 6, 2, 4, 6, 8. Who do we appreciate? Apparently I like even numbers because I chose even numbers on top as well. But we're going to take our 2 and apply the formula. So 2 times 2 is 4. So 2, 4 would be your ordered pair. 4, plug that in there. 4 times 2 equals 8. And now we have our 3 ordered pairs, and we can plot each point on the coordinate plane. So 2, 4 would be here. 4, 8. Start with the flat line. Again, this is the x, this is the y. X is first. 4, twice as much as 8. 6 and 12 right up at the top there. Notice that when you multiply, your lines are quite slanted. I'm sure there's a more mathematical way of expressing that, but for the 5th graders, that's all we really need to know, is that if you add to x, if you're adding to it, we've talked about if x equals y, you get a line right straight through the origin all the way through your graph. And look at how the line that we made when it's plus 4, you just go up and it's still parallel with that bisector. When you multiply, it is definitely not parallel with the bisector. We start to turn these lines up, so it's what we're calling a steeper line, okay? So notice these things, because we actually do have to describe similarities and differences in upcoming assignments, pages, lessons, questions, blah, blah, blah. Okay, use a straight edge to draw. We did it. Give the coordinates of 2 other points that fall on this line. That means use the rule. Use the rule we came up with, which is 2 times x, okay, with y coordinates greater than 25. So we want our y coordinates to be greater than 25. If you want to multiply something, you can choose any value. You can even choose a fractional value, but I'm not going to do that for you because kids will get lost and confused. So let's take a number like 15 for x. If you multiply 15 times 2, you'll get 30. And that fits the requirement of the y being greater than 25. You can also do something like, say, 20, and then 20 times 2 is 40, and our y is greater than 25. Okay, so we don't have to plot the points. Obviously, you can't because the graph doesn't go far enough. but they want you to know that these points will also be on this line. It'll just be way out here off the page. Turn the page. And now I'm going to straighten you back out. Okay, and while this focuses, we will read. Use the coordinate plane below to complete the following tasks. Good thing it's the same. Now this is going to be one line, this is another line, and this is another line. So we're going to have 3 lines on this graph. This is when it gets really fun. Okay, line L, x is equal to y. So much fun when they start us off with this one. If x is equal to y, then whatever you put for x, look at what you're counting by, what are your options, then I can do the same thing. So let's start out with like a 5 and a 5. 5, 5, because they're equal. And then let's do like 8, 8, because they're equal. And how about 12, 12? Now we're going to, we have to actually create it. They don't tell you to plot the points or connect, but that's what we're going to do. So 5, 5. 1, 2, 3, 4, 5. Sorry, that looks off. 1, 2, 3, 4, 5. Got double check. Can never be too careful. 6, 7, 8. 6, 7, 8. Right here. That's my 8, and that's my 8. And then 12, 12. 12 is here, up. Now we're going to go right across to here. And that's my 12, 12. We're going to connect our lines, and you should know, and you have to be really careful when you put your straight edge down. If the rule is x equals y, then your line should bisect your graph right through the origin, all the way through the middle. Now this is line L. Don't forget to label it, okay? Next line is line M. This is where it gets fun too. Y is 1 less than x, okay? Now we've done a lot of addition, we've done a lot of multiplication, but now we're going to do something to go down. So let's give x a value other than 0 because we have to take 1 away. So let's give it a 5. If x is 5, then y is 1 less. So your formula is x minus 1 equals y, and that's just a dot, and it's not a division sign. It's just a printer little blurb, okay? So x minus 1 equals y. So now take your 5, that's the x, take 1 away, and you should get what? 4. So my ordered pair is a 5, 4. Let's do it again. In fact, we could use the same x starting point, but you don't have to. And you can come up with any points you want. I would say don't have anything don't do 0 here. You could have 1 through 15, okay? And come up with your own points. You can do 12 and 14 if you want. But the y will be 1 less, so we'll have 11 and 13. Make your ordered pairs. Put the parentheses, yes it matters. Put the comma, yes it matters. Plot the points. 5 and 4. Here's your 4. 12 and 11. Here's your 11. And 14, 13. All the way out here to the 14. Up, because I know it's going to be right below the line. It's going to be right below line L. Because look, it's separated by 1 unit on the graph. This is separated by 1 unit on the graph. This is separated by 1. Now we're going to connect our points all the way through the whole graph. Hold that ruler steady and label line M. I like to label them in cursive, kind of like they do. I don't know, just because it's fun. Try it. Okay, line N. Y is 1 less than what? Twice x. Now here's that twice again. Twice, I think, do we use that on the homework or the problem set? So I think it's in the problem set. Yeah, here it is. 1 more than twice x. We have 1 less than twice x. So we're practicing with subtraction again. And so whatever you do with your x to double it, that comes first. And when you get twice x, we're going to take 1 away. And so all that will give you your y. Okay? So you're going to multiply by 2 and then subtract 1 in that order. So come up with whatever you want for your 3 points for S. Okay? And again, think about, I have to double it. So you don't want to go bigger than 7. Because if you have 8, well, you could do 8 times 2 is 16, which is off the graph, but then you're going to subtract and get 15, so you could do 8. That would be the maximum number. But I would say, let's just keep them a little bit less than 8. So you can do, let's say, a 2 and a 3 and a 5. We'll go with some odd numbers now. And so 2 times 2 is 4, minus 1 is 3. And 3 times 2 is 6, minus 1 is 5. And 5 times 2 is 10, minus 1 is 9. And so now you have your 3 points, which you need to put on your graph. So 2, 3. And if here, 1, 2, 3, 4, 5, that might help you to find your points. 2, 3 would be here, and then 1, 2, 3. 3, 5 is right here, and it's labeled with the number. And 5, 9, up, 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 up. There we go. Okay, notice these are not parallel to lines L and M, but that is okay. And we're going to connect our points. Even though they don't say, you just need to do it. Okay, so do any of these lines intersect? So remember that an intersection is a crossing point. If yes, identify which ones and give the coordinates of their intersection. I guess I should have been a little bit more careful with these points, but here we go. Yes, this is line N. Label it. Okay, and then the lines that intersect, well, it's going to be all of them, but N intersects. And if you didn't make your lines super long, you might only intersect with L. And the point that it would intersect, which I didn't make a very good point there, but it's supposed to be at 0, 0. Hopefully yours is better. And the intersection is really supposed to be right there. See, precision matters. Okay, so N intersects with L, and it should be intersecting right here. This N will intersect with M, but it will intersect off the graph. That's why we don't have to worry about that one on this question. Are any of these lines parallel? Remember, parallel lines go forever in the same direction. They don't always have to be facing this way. They could be facing this way. They could be facing this way. They could be facing this way. It doesn't matter. They're going the same direction, like a pair of L's forever in the same direction. Yes, we have parallel lines, L and M, and we've identified which ones. And then give another rule. Give the rule for another line that would be parallel to the lines you listed in problem 3C. Boy, they don't want to give anything away. So what's the rule for line L? Line L is x is equal to y. And then the rule for line M is y is 1 less. So kind of in the same way that in the problem set we identified that if you add to the x equals y, you're going to get a parallel line that goes above the bisector. In the same way, if you subtract from x, you will get a parallel line that goes below the bisector. So the rule for any other line that would be parallel to the lines that you listed, x minus 1, x minus 2, x minus 3, those would all work. X plus 2, x plus 3, x plus 4, that would all work, okay? All those would work. So you just have to add to x or take away from x in order to have a line that's parallel. Okay, and that's really all there is to it. So I hope this is helpful. Again, click subscribe and come back, and we'll see you on the next video. Bye for now.